This is not a Git tutorial. This is us rebuilding Git from nothing in about 150 lines of Python. Same file, hashed by real Git, then by our code. Identical hashes, byte for byte. In 2005, the Linux kernel team lost access to their version control system, BitKeeper. Linus went quiet for about 10 days and came back with Git. It had to be fast, distributed, and bulletproof against corruption. Git is a key value store. You hand it some content, it hands you back a hash of that content and files it away under that hash. The same idea is behind IPFS, Bitcoin block hashes, and the Nix package manager. Every repo starts with a few folders. Init makes an objects folder, a refs folder, and a head file that records which branch we are on. No database, just files and folders. Take the raw bytes, glue a tiny header on the front saying the type and size, and run it through SHA-1. That 40-character hash is the object's name. The header matters. Without it, you get a different result than real Git. A name that is also a guarantee. Identical content always gives the identical hash, so Git stores it once. Change a single byte, and the name changes completely. Just 2 hashes tell you whether the contents match. With the name in hand, we save the bytes. Compress them with zlib and write them into objects in a subfolder named after the first 2 characters of the hash. Exactly what real Git does. To read an object, we open that file, decompress it, split off the header, and we are left with the original content and its type. A clean, round trip. The simplest object is a blob, the contents of one file. Hash it, read it straight back, untouched. And hash the same file with real Git, the exact same hash, bit for bit compatible. Open any Git repo on your machine and look inside the .git folder. An objects folder, a refs folder, a head file. The same 3 pieces we just built. Git has no database. It is just files. To capture a whole directory, we need a tree, a list mapping each file name to the hash of its blob. We hash that list too, so a directory also becomes one object with one name. A commit points to a tree, the tree points to its blobs, and every one of them is just a key value entry. A graph of hashes, every node named by its own content. This shape is the heart of Git. A branch is a tiny text file that holds one commit hash. The word main is just a file name under refs/heads. Git has no branch data type. Branches are a user interface on top of files. Head is the pointer to where you are. It says, I am on the branch main. So to find the latest commit, we read head, follow it to the branch file, and read the hash inside. A commit records the tree for this snapshot, the commit before it, an author and committer, and a message. Then we hash it, just like everything else. Every concept in Git becomes the same kind of thing, an object with a name. Making a commit advances the branch. We write the new commit's hash into the branch file. The pointer moves forward, and that is what committing really means. History does not move, the label does. Each commit points back to its parent, and a branch is just a pointer into that chain. History in Git is hashes linking to hashes. The links themselves are the timeline. Initialize a repo, snapshot a couple of files into a tree, and make the first commit. Then do it with real Git on the same files, and the tree hashes line up perfectly. We are not mimicking Git. We are Git. To show history, we start at head and walk backward. Read the commit, print its message, follow the parent link, repeat until there is no parent left. No database query, just a loop following pointers. Make a second commit, then run our log. Both commits print newest first, and because each commit names its parent by hash, history cannot be silently rewritten. What changed between two snapshots? We pull the content of two blobs and hand them to Python's own diff library. Git does not store diffs. It computes them on demand from whole snapshots. People assume Git stores patches. It does not. Git stores whole snapshots and works out the difference between any two of them on the fly. Storing everything is cheap because identical blobs dedupe for free. Take a stored object, flip a single bit inside it, and ask Git to read it back. The bytes no longer match the hash, and Git refuses. Corruption, detected by design. Every read is also a checksum. Same repository, same files, same commits. Real Git log on the left, our log on the right. Same hashes. We started with one matching hash. Here is the whole chain matching. Everything together, end to end. In it, two commits, a log that shows our history, and a diff between versions. A working Git, and you watched every single line of it appear. Real Git adds a staging area, packed files, merging, and remotes. And merging is where this design really sings. Walk two commits back to a common ancestor and rebuild from the result. The full track is on iwtlp.com.